Alright, hello, welcome back to Lesson 5. Lesson 5 is all about making choices. And to do that, we're going to talk about the Boolean first. Boolean is another new type, and Booleans are very simple. They can essentially be either true or false. That's it. A bool is just two values. A way to say it could be this or it could be this. And we can assign them to variables, much like we would with any other type. X is now true. And if we look at the type of X, it is a bool. Now, true and false in this way are very simple, but we can also generate them from expressions using equivalence operators like less than or equal to. So, for example, if we would say 3 is less than 7, this is a true statement, and unsurprisingly, it returns true. We can say less than or equal to, we could say 3 is not equal to, we could say 3 is greater than 7, which is obviously false, so that returns false. And then we can assign these expressions to our variables. And then we will get some value back, true or false. This is, as you can imagine, quite powerful. So what would you do with this? Well, this is where you come to if statements. If statements look a lot like for loops. We say if, and then we provide some expression that will evaluate to either true or false. And then, let's say we'll do if x. If the value of x is true, then new line, colon, new line, indented, then we have an if block. We print x is true, exclamation mark. There we go. So when we run this, if x is true, we print x is true. If we set x to false, and then we run it, nothing will happen. Because it's saying, okay, this is not true, so we're just going to ignore all of this code. As before, once the indentation is over, that's when the rest of the code can begin. However, quite often you want to say, is something true? Okay, well, if it's not true, then what do I do? So you could have else print x is false, exclamation mark. Now, whenever we execute this, if x is true, this code is executed. It then moves on to the else statement, if x is not true, and executes this piece of code. That way, at least one of these pieces of code will always be executed. Finally, there is one other aspect we can introduce. So let's make this a bit more complicated first. Let's say if x is less than or equal to 7, print x is less than or equal to 7. And then let's say for else, x is greater than 7. In fact, let's have this as x is less than 7. So there we go. So we're printing out x is less than 7 or s is greater than 7. Now, the reason this code executed is because of an interesting aspect of Booleans. Booleans are actually, they inherit from integers. So, true is actually the equivalent of 1. So if we would convert this to an integer, you'll see that that is 1. If we convert false to an integer, that is 0. Okay, anyway, back to if. Now we have, let's assign a value to x. Let's say x is 9. Okay. So if x is less than 7, we're printing x is less than 7. Otherwise, we're printing x is greater than 7. Great, that works. What if we set x equal to 7? It says x is greater than 7, but that's not true. But there's the else statement. In other words, we need a third option. We've got less than 7 and we've got greater than 7. But what about equal to 7? Well, we can add in what's known as an else if, or elif. And now we provide a new expression, x is equal to, and we use two equal signs to imply equal to, because a single one is the assignment operator, colon, print x is equal to 7, exclamation mark. Now, you can have as many else ifs as you like. You can only ever have one if and one else, but you can have many else ifs. And an important thing to note is that when you run this code, if this one evaluates to true, none of the others will be triggered. They won't even be looked at by the code. You can have operations that change the value of x in them and they won't be called. This code is just completely ignored. The same is true here. If this is false and then this is true, then this code is executed and this code is just ignored. So none of this may ever get called if this is always going to be true. So what can you do with this? Well, quite a few things, as it turns out. A very common one is in programming interviews, people are often asked to write a FizzBuzz algorithm in Python, maybe just for the first 100 or so numbers. Now, we can do that with all of this knowledge that we have. So FizzBuzz, for those of you that don't know, it's a counting game. You count from 1 up to, well, as high as you wish, and you replace any multiple of 3 with the word fizz, any multiple of 5 with the word buzz, and any multiple of 3 and 5 with FizzBuzz. So, we would do 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz, 11, fizz, 13, 14, FizzBuzz. That would be the first 15 numbers. And you can write that. We could do it like this. I in range 100. In fact, we want to start at 1. So we do 1 to 101. If I divisible by 3, this is the modulo symbol. I'll just take a moment to explain it. The modulo symbol means I'm going to take this number, I'm going to divide it by this number, and if there is anything left over, that's the return. So if there's nothing left over, i.e. it returns 0, that means that I was divisible by 3. Okay, so we say if I is divisible by, the remainder of I divided by 3 is 0, that means it's divisible by 3, and I divisible by 5 is also equal to 0, print FizzBuzz. Else if I divisible by 3, 0, print fizz. Else if I divisible by 5 is equal to 0, print buzz. Else print I. There we go. Now, you may wonder why I have done it in this order. This is because, if we look at this, if this is the first statement that's going to be checked, correct? Which means that if I is divisible by 3 and by 5, FizzBuzz will be triggered. But if I was just divisible by 3 but not by 5, then this isn't triggered. We move on to I divisible by 3. Then, if that's divisible by 3, we print fizz. If not, we move on to the next one and check for buzz. If not, then we use the last one, which is none of them are true, we print I. Now, I've also used something a bit sneaky here, which I haven't mentioned yet, which is AND. AND allows us to string statements together, as well as OR. So let me just execute this code, so you can see how FizzBuzz works. So we got 1, 2, fizz, 4, buzz, fizz, etc. Just as I demonstrated. But to do it, we use the AND statement. AND combines things. True and true will return true. True and false will return false, because both values need to be true for AND to return true. You can also have true or false. So, for example, this would probably be better explained with variables. X is 7 at the moment. Let's make X true, and Y is false. So if X and Y, then that would require both X and Y to be true. But they both equate to, one of them equates to false, so we get false. Say, or only one of them has to equate to true. And you can stack this with as many ands and ors as you wish and expressions as you need. Okay, so we've looked at bools so far. Now it's time to look at something a little bit more complicated, but still on these basic principles, which is Boolean arrays. Now, Boolean arrays are pretty unusual, but they're incredibly powerful in NumPy. We're going to go back to the data we had before. So we've got data, numpy.loadText, and we've got simulation data, where we skip the first 52 rows. Okay, so let's say x equal to sim, y is equal to sim, and then we've got z as well, which is our color data. And that's the third column. Right. So what we can do is we can look at things in these data. So in a NumPy array, we can say x is less than 10. Now, in previous lessons, you'll have seen that if you multiply something by something, an array by a scalar value, it multiplies every single element in that array by that value. The same is true if you do an expression. It turns your array into a Boolean array. Every single element is converted to true or false depending on how that expression evaluates.
I don't mention it here, but it is actually possible to do this element-wise between two arrays. If you equate two arrays, like in this animation, you can see that you end up with an array of trues and falses, depending on how they evaluate.
Now, we can use this because you can actually index arrays using this. If we were to feed this into x, so we say x less than 10, what that's going to do is it's going to find all of the elements where x is less than 10 is true, put them all into one array, and return that. And this way, we can extract all of the elements where a certain expression is true from our array.
To emphasize this point further, if we take the array of bools, the 3x3 C from the previous animation, and then feed that into this new array of strings D, we can see that we get out this one-dimensional flattened array of the results.
Now, another little caveat here, or more of a feature, is that this will work provided the array you're indexing is the same shape, but they don't have to be the same array. So what I can do is I can say, I want all of the values of y where x is less than 10. Or I could do the same for z. And this is how we're going to take a cross-section through our data. So first of all, we want to find the smallest value of y, not really the lowest, we want to find the smallest. So what we can do is use the absolute function, which will change the value to a positive one because y contains negative values. So we can say, what is we use numpy.amin, which is take the smallest value, well, take the lowest value, the minimum value of the absolute value of y. What is that? I haven't imported numpy as np. numpy. There we go. That's 0.25. Right, so y is equal to 0.25. That will be a Boolean array, and wherever it is true, that will be where y is equal to 0.25. So we could get a load of x's from that. There you go. That's all the x values where y is equal to 0.25. And we can assign that to x. We can do the same with our luminance. Y is equal to 0.25. There we go. So now we've taken a cross-section. It was that easy. It really is very straightforward. So let's get back to matplotlib. Let's create a figure. Create some axes. and x.plot, and let's have x, z, and let's use, let's say no line, so we set the line style equal to be blank, and a marker, let's use a cross. Cross, there we go. There we go, and if we plot this data, it didn't turn interactive mode on, so let me just do plt.show to bring that into existence. If we look at this data, that's our simulation data. You can see it's got these little spikes, those are for each LED, and we've got a pretty clear distribution. Now what we can do is, if I just close this now, I'm going to do data. We've got data actually already, haven't we? We've got data here, so we can do x.plot on the same plot, data, or the x data, and then the y data, and this is for the experiment this time, and we can plot on the same one. I see. I meant to do colon, comma 1. There we go. And now if we do plt.show again, yes. So because I created the thing and then I closed it, the file no longer exists to be shown. So what we can do, I'll just create a new figure with new axes and then plot the simulation data and the experimental data. Now if we do plt.show, we've got a new figure which contains both sets of data. Figure 1, there you go. We can see the experiment and how it overlays with the simulation. And you can see it's a pretty good correlation. These look like they're probably the same material, even if there's a lot more noise in the middle in the experiment than there is in the simulation. Okay, cool. With all of that, we're going to end this lesson.